Welcome everyone. Good morning and good afternoon and good evening, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. My name is Satya Ramesh and I will be the host for you for the next few minutes. And before we begin the webinar, I'll just walk you through what we do and what we have done over a few years as a Data Platform Geeks unit. So what we had started in the year 2004 as a small user group meeting with 7 people has been transpired into a greater community of work at this moment. So in the year 2004, a small user group meeting had happened. There was no community that time. There was no name that time. Then later, few more people joined in, and the year 2010, we formally formed SQLServerGeeks.com. Then onwards, we have multiplied our community effort. We have done a lot of webinars, in-person events, etc. And in the year 2015, we have hosted first Asia SQL Server Conference, that is SQL Server Geeks Annual Summit 2015. And continuing the success, in the year 2016, we again repeated SQL Server Geeks Annual Summit 2016. And everything is changing, and SQL Server is growing beyond what it was, and data platform was the new buzzword that time. So we also upgraded ourselves and formed dataplatformgeeks.com in the year 2017. And at the same time, we have rebranded our SQL Server Geeks Annual Summit as Data Platform Summit. And from 2017 onwards, it is Data Platform Summit. And 2018, 2019, we have continued in-person events. And from 2020 onwards, because of the obvious reasons, because of the pandemic, we have gone virtual, and at the same time, we have gone global as well. So 2020, 21, and this year also we are doing Data Platform Virtual Summit 2022. You can go ahead and browse all other things that we do, webinars, in-person event, virtual symposiums. Everything is up there in the dataplatformgeeks.com for you to browse what we do. And here is a small picture that we cherish. This was the picture taken just after the keynote of Data Platform Summit 2019, which happened in the Bangalore Radisson Blu Hotel. So just after keynote by corporate Vice President Gail Shepard, this was the picture that we really cherish. So from there, from 2004 with 7 people to this picture in 2019, where we have hosted more than 1,000 people in single event, we have done a lot, as we usually think. And once we gone global, we have increased our reach, and now in the year 2022 we have 165,000 plus people from 91 different countries. So we have become a Superman right now. And a lot of countries, people from a lot of countries started joining in. This is a small illustration from a few years back, and this is another illustration that from the last year's conference, top 20 countries that participated in Data Platform Virtual Summit. And another good news is that Data Platform Virtual Summit 2022 is announced. You can just go to dataplatformvirtualsummit.com, and the good news is it is free for everyone this year. So it's a very important thing, friends. Just go to dataplatformvirtualsummit.com. All of you can register to the summit for free. And 1 week before the summit, we do 8-hour virtual trainings. Those are called as pre-conference training classes. So we have announced 12 pre-cons. So here is a list of 12 pre-cons. There are a lot of technologies are being covered: Power BI and Azure Synapse by Dave, and extended events by Jason, Query Store by Milos, and our today's speaker Tomaž is doing 8-hour virtual training on Spark for data engineers. We are also doing something on Power BI data modeling and Power BI performance tuning by Nicola, and advanced analytics with T-SQL by Dejan Sarka, and ETL in the cloud by using Azure Data Factory by Dennis Torres. And few more precons are also there. One is SQL Server Performance Tuning Magic Show by Guy Glanster, and other one is SQL Server Performance Tuning and Troubleshooting by Dennis Rajnik. And we have one class on PowerShell by Ben Miller, and we're also doing one precon on Synapse Pipelines by Abhishek Narayan from Data Factory Microsoft Group. And today's speaker Tomaž is doing 8-hour virtual training on Spark for data engineers. He will talk more about what he's going to cover in some time at the end of this webinar. But if you are attending this webinar, if you want to register for this training class, there is an exclusive discount code only for you. Just look at it, 60 steal it. I'll again share that in the chat window, but 60 steal it will give you 60% off on any training class that you wish to purchase. So our training classes offers a true value. The price is slightly bigger than what you see on the screen. So at this moment, it is close to $200. And most important thing is the price is going to increase from August 1st onwards. So if you wish to book any training class right now, this is the right time. And other than precons, as I told you, Data Platform Summit is free. And this year we have done a lot of improvements. We are doing multiple editions. So Data Platform Virtual Summit will happen 5 days, starting from September 19 to September 23. September 19th, we do ANZ edition. The next day we do APAC edition. On the next day, we do IST edition, then EMEA, and then Americas edition. So if you register for Data Platform Virtual Summit, you can attend all the editions. There is no restriction that you can attend only one edition. You can attend any edition. Registration is only single registration. And to improve our diversity efforts, we are bringing multilingual content this year. There are more than 30 sessions that are happening in non-English language. Few of the languages include German, Portuguese, Spanish, Hindi, Chinese, Hebrew, etc. I just called few. There are 14 to 15 different languages other than English that are being covered. So this is the only conference in the globe that is covering multiple content in the multiple languages. And a special concentration on SQL Server 2022. SQL Server 2022 launch is around the corner. We never know when it's going to be in the public. I think soon it will be in public. So we are having a special concentration, special track on SQL Server 2022. So as we usually say, content is king. You can just go to dataplatformvirtualsummit.com and go to a sessions page. There are close to 200 sessions that are already announced, and you can explore them. If anything interests you, just go and register. It's all free. And you can also explore our technology coverage. And if your company wishes to participate in our knowledge partner program, it's all up. Just go to dataplatformvirtualsummit.com. There is a KP page, or else you can simply drop an email to kp@dataplatformgeeks.com. So someone from our team will revert to you and we can take it forward from there. So with this, friends, we're all set. You can evaluate Data Platform Virtual Summit 2022. You can register for free for the regular summit, and pre-cons are highly discounted at this moment. So bookings are open. You can go and register right now. A special thanks to Microsoft for supporting us in our community efforts, be it SQL Server Geeks, Data Platform Geeks, or Data Platform Summit. Microsoft is always supportive. There are few links here, friends. If you wish to join, follow us in Twitter, Telegram, YouTube, any social channel that for that matter, we are available there. After this webinar, you'll receive a thank you email where you'll get all the links again. So quick housekeeping announcement. As usual, we are all used to the virtual world these days. So please keep your microphone muted and please use headphones, earphones for the best experience. And we will take the questions at the end of the session. So during the session, if you have any question, please put that in the Q&A panel. At the end of the session, speaker will pick up the questions and answer. If you face any audio or video issues, please try a different network and try to rejoin. Sometimes that works. So the most important thing is we will share a feedback link with you at the end of this webinar. That is very crucial. So please share that. So with this, friends, we are all set to begin the webinar. Tomaž, over to you.
Thank you. Such a very beautiful introduction. And I'm going to share my screen now and we'll fire it off. Perfect. So good morning, good afternoon, good evening, everybody. Welcome to Data Platform Geeks. My name is Tomaž Kaštrun, and I'll be giving you a easy introduction to Spark for data engineers with Azure Databricks. So why I've chosen Databricks for this session is primarily because it's fairly simple to set up the compute, set up the whole platform, and it's much easier to actually just start writing the code, doing all this data engineering stuff that you need for your project or you need for the data warehouse or anything. And that's why I'll probably just blaze through the PowerPoint presentation, and then we'll go into the demo. If you are interested in demos, so the demo is available at my GitHub repository. You can scan the QR code or just go there and make a clone. Anyways, a couple of words about me. Been working with SQL Server and data analytics for more than 20 years. Am a avid coffee drinker and bicycle junkie. But otherwise, I do a lot of data analysis and BI development, data science, and stuff like that. And side note, today I will definitely not go into data analytics that much. I just want to give you sort of a brief overview and a gentle introduction to Spark. So agenda for today, what is Spark and why Databricks? As I've already explained, why Databricks, because I don't want to waste too much time today setting up the clusters and images and just getting all the infrastructure working. For that matter, if you're interested in the subject and want to get deep dive, join me with the workshop, the one that Satya actually introduced a couple of minutes beforehand. Anyways, I want to go through where is Spark, where we can find Spark in everyday life, what are the modes of execution, what is Rdd, what is data frame, data set, and what is actually Spark API. And we'll dive into all those demos that are actually available for you if you make a clone of that repository, primarily Scala and Python. So a couple of words about Apache Spark. So Apache Spark has been around more than 10 years now. It's fast, multi-purpose, in-memory cluster computing framework, compatible with Apache Hadoop, especially built to sort of deliver the speed and the ease of use for any type of data engineering or data analytics. It has been, ever since growing, the large community has basically created around. So, there is not only a lot of material. Databricks actually is one of the projects that essentially came up out of that Spark, but also there's a lot of books, a lot of demos, everything actually available. And why is Spark becoming so much more important is primarily because a lot of new technologies have developed around the concept of Spark. So, for instance, Azure Synapse is something that was, basically developed. Prior to that, HD inside Azure, HD inside. Today, if those who've learned that, for instance, SQL Server Stretch has been deprecated, any idea going from Stretch table or Stretch database to something similar to Spark, which again is the basic idea around that. And also in the version of SQL Server with big data clusters, again, the concept of Spark was essentially there. So Spark is gaining a lot of traction, not only in the community, but also in technology. And a lot of these new technologies are sort of going into the direction of Spark. So this is the reason why Spark is becoming more and more of a main player in this world. A couple of use cases. So Uber, for instance, is using, Twitter is using, Yahoo, Netflix, Pinterest. All those companies are using Spark for any type of either analysis or data in data aggregation, real-time data analysis and stuff like that. So, if you go online or if you go and check any of those companies, you will see that there's been a lot of different companies doing something based on top of Spark. So Yeah, all those. There is also the real-time framework worth mentioning, like Apache Samsa, Apache Stormer, Apache Flink. So those are also frameworks available on top of Spark that basically enables you real-time analysis and workloads. The latest stable version has been just recently announced, but today demo, I will be using 3.2.1 in Azure Databricks. And there has been quite a lot of improvement over Spark 2. So we're talking about Spark 3 now. Especially Python was deprecated, adaptive executions, dynamic partition pruning was introduced, support for deep learning, better Kubernetes integration. Delta Lake is also something worth mentioning, especially if you're doing a lot of ETL or data transformation stuff. So, of course, Apache Arrow as well. Just to give you a hint, where does Hadoop and where does Apache actually, how do they work together and what is the difference between those two? So especially if you're looking this big data frameworks, you can see that Hadoop takes, a lot of data movement and a lot of network movement for each step, whereas Apache Spark can actually, for each step, it can sort of cache the data into the memory. And also there is quite a different set of other services available. If you're using Hadoop, for instance, there would be Hive or Flam or Peak, whereas with Spark, there would be primarily only APIs that would do all the work essentially for you. So every time you're using, for instance, any kind of language, whether it's Python on Spark, whether it's Scala, whether it's R, whether it's Java, there is always some API on the back, on the level underneath that would essentially create your job much easier and much faster. And there is also, for instance, batch processing and stream processing, again, available with Hadoop or with Spark. But coming, closer to ecosystem, you will see that, as I said, there are 4 languages supported, and there is not Markdown mentioned, but that's something that in Databricks you will essentially see that you're basically operating with notebooks. But then there is the core engine, and you would have Yarn, you would have Mesos, you can have Kubernetes. There is a standalone scheduler, and once you hit the core, there are APIs that essentially do all the stuff. So we're talking about Spark SQL API, streaming API, machine learning API, and so on and so forth. So again, Spark essentially is agnostic. So you can have it in Azure, you can have it in AWS, you can have it in Google Cloud Provider, or you can just grab Databricks, again, agnostic in terms of the cloud provider. The functionalities, there is the idea and the notion of these Rdd files, resilient distributed data set, which is the main data structure for Spark, and then there is direct acyclic graphs, the use of how the data is actually understood, how the execution plans are created, and then how the RDDs are sort of combined together. But the core functionalities are task scheduling, management, memory management, fault recovery, storage, stuff like that. If we take a deep dive into Spark SQL, we can see that you would have essentially your ANSI SQL language available, where you would operate through data frames. The tables can be represented on top of Rdd files or any other API. And of course, there is also a native support for Hive, Parquet, JSON, CSV, stuff like that. In terms of the streaming, there's a lot of data analysis on if you're doing a lot of streaming, there would be perfect solution would be going with Spark, whether it's Kafka, whether it's Mesos, whether it's Kafka or Flink. For instance, if you're having a lot of tweets, if you're having a lot of log messages, Scala, stuff like that, there would be Spark streaming would be a perfect solution for you. There's a high throughput, full throttle, and end-to-end, and it reads exactly once. And then there was, again, coming from Spark 2 to Spark 3, there was a huge improvement in terms of the continuous processing for the Spark streaming. And then there is the Spark, their own machine learning library that has a lot of functionalities available for you, and also graph data set or the use of graphs in terms of, if you're doing any type of networking data, there is this API available that can essentially do that. Coming back to the Spark, and again, this is slightly not related that much to Databricks, because essentially when you just fire up the Databricks, there won't be all these possibilities available. But I just want to point out, that you would have essentially 4 different modes: standalone, cluster, Mesos, and Yarn. So, and today we'll essentially be, in Databricks going from either standalone to cluster mode. So, and everything is based on Java virtual machine. So every time you fire up a cluster, there would be sort of like a machine in the background that would sort of communicate with a master machine. So in order to do that, there is so-called Spar Context, which is sort of like a driver application that communicates and distributes the commands through to the workers. And again, there is type of execution modes, so you can have a local, cluster, or interactive. In terms of the local mode, everything is on single machine, and then you would have the driver, the schedule, the master, the execution. So essentially all those elements that would help you fire up the parallelization and the computation, through different nodes or machines. Why is this important? You might ask. Well, again, not in the Databricks, but if you are, somewhere out, creating your own environment, all this stuff will definitely be worth understanding, especially when it comes to troubleshooting. Sometimes you would then refer, okay, so what is my master virtual machine, or who's the executor, where the data resides, what went wrong, and stuff like that. So this definitely comes in handy. Again, today we'll be essentially using the cluster mode with Databricks. How does the cluster mode sort of works is that there is the driver program, there is the cluster manager, and everything is sort of distributed through the worker nodes. So the worker nodes are actually essentially the virtual machines that do all those little tiny tasks. And once we'll go into Databricks and fire up a simple job, you will see that every time there will be different, number of jobs, or that you sort of say, okay, do something. You would see that there would be like one Spark job or fired, or 4 Spark jobs fired. So this means that every time there would be a worker node sort of firing, sort of, working on a virtual machine. Again, components, feel free, as I said, PowerPoint presentation is available. So just, you can read it and go through any given time. But the worker is essentially a node in a cluster, and it executes, executor manages the computation, storage, and caching for this worker. The cluster manager sort of allocates the resource via this context that we've already touched upon. And then there's the driver program, sort of like a holding Spar Context, sends application code to executors and listens to incoming connection from the executors. So essentially, in order to have this parallel massive computations, all those components need to be created or set. So with a standalone cluster, it's slightly simplified, but then again, it is the same. And then we have so-called execution processes. So data preparation, transformation, creation and execution. So I just want to briefly mention it. I don't want to go too deep. With data preparation, you would have Rdd file creation, sort of like parallel data sets. Then you would have the transformation or actions, where you would sort of create a task and then it would be executed. And then creation of this acyclic graph, which sort of like contains a graph how the Rdd would then understand which task need to be created or executed. And then, of course, the execution of a program, which is sort of like an application. Another concept to keep in mind is shell versus cluster. Shell is interactive versus the cluster mode is sort of like, you sort of create an application. How do you create an application? Again, this is a very pseudo code. I'm not touching this today, but once you sort of create your environment with Spark, you can easily submit an application, which essentially would mean, I will be firing up this particular Python file through my environment, defining the class, the master, the deployment mode, and any additional operations that you would essentially need to do. And this is the difference between locally and local and standalone cluster, or the Mesos and the Kubernetes. And you can see that essentially, all the main attributes parameters needs to be defined. But then again, there is always the jar files, path to example.jar, which is essentially a zipped jar file with different executions, whether it's a Java file, whether it's a Python code. You just sort of say, okay, now do execute this in my Kubernetes and return the results or write the results somewhere in the blob store, for instance. Rdd files, as I've mentioned a couple of times, resilient distributed data sets is sort of like the basic presentation of data in Spark. It is a distributed collection of items or partitions, and they are immutable, which means that once a Spark creates an Rdd file, it cannot be changed. In fact, it will create a new Rdd file from this previous Rdd files. And this is then perfect whether you want to do a caching or whether you want to create a different storage levels for different Rdd files. And RDDs, of course, support transformation and actions. So we'll talk about transformation and actions a little bit further down the road. There are also a couple of computations, so you can create an RDD, transform an RDD, and then also, as I said, actions, which essentially RDDs are essentially lazy. Unless you say assign an action, it will sort of just create a schema in this DAG file to understand how it will be operating with the file. And yes, RDDs are sort of distributed across the nodes. Operations, transformations, and actions. So transformations are lazy, which means that essentially nothing will happen in the background. It will just sort of prepare, let's say, quote unquote, execution plan, what it needs to do. You might have narrow wide types. You might have examples like, map, filter, join, group by, and actions are the one that essentially will create something out of this, this execution plan, quote unquote. So actions will return something, whether it's through count, through collect, through save, through store, to write, to read, stuff like that. So actions are, the ones that sort of, creates and wakes up the clusters, the workers that then essentially do something with the data and then return it to the cluster manager or to the collector. There are narrow and wide. The difference between those are because RDDs are sort of created in partitions. Sometimes you need to take a section of partitions and sort of create new partitions or new Rdd files. And this, what we've called is transformations. And then again, actions are once you do something with this. Again, narrow and wide are just two different type of actions. transformations. Just to give you a sense, what is transformation and what is action in terms of the functions. So you can see the transformation is sort of like map, filter, sort, group by, sample, union, and stuff like that. And then actions would be reduce, collect, count, save or read to file and stuff like that. So this is essentially the difference between transformations and actions. Once you fire something with Apache Spark, you would get also the so-called web UI, which essentially will help you explore and understand how the Spark essentially behaves. You can also do any type of creation, basic transformation. All these will essentially be available for you through this UI, essentially meaning that any type of definition, function, method you create, a class, everything will be available through this web UI. How does the web UI look? We'll definitely go into and check in Databricks, but essentially it is sort of, each step is aggregated and you can deep dive in all of these steps, try to understand what has happened with every of those steps. And then again, this is the deck visualization, how the Apache Spark essentially understands what it needs to be doing, what type of operations and transformation it needs to be working on. I've mentioned structured API. Nowadays, with Spark, everybody's using structured API because it's extremely fast. And structured API are faster and much easier to adopt, and start using it is essentially much easier. Just to give you a quick notion, with Rdd files, again, you can see this part here, how to create an Rdd file. You have to sort of, create a Lambda function, tell Rdd file how you want to reduce by key and how you want to map it. Once you do that, bam, you get the results back. Whereas with SQL API or structured API, essentially, this is a representation of SQL language, which essentially is much simplified or easier, and that's why everybody nowadays is essentially using structured API rather than Rdd APIs. And also in terms of the performance, also the structured API is much faster. There are also some differences and some problems. For instance, if you are using typed or untyped and going through Python or Scala, you will definitely you have to understand or have a notion what might happen in terms of different data types. Again, just to give you a quick overview, the data frame API on the right-hand side versus the Rdd API on the left-hand side. So essentially, everything that is encircled in these green rectangles, you can see that essentially it will create the same file, the same data frame or data set, but the understanding of two different code is much easier to comprehend the data frame API. So the data frame API is, as we like to call it, is much more readable, and it allows you to have sort of like a structured representation of your data and rows and columns, something that we've grown to understand through database tables. And also it helps you to assign the schema, which is definitely a huge plus when it comes to integrity issues. Okay, what I'm going to do now is I'm going to jump into Databricks, and we'll go from there on and see what is Databricks, how to behave with Spark, and how to basically work your way around the Spark, Apache Spark. If there are any questions, just let me know. Okay, for those who are not familiar with Databricks, so what you're going to do is you go to you go to your dashboard. So you log into the portal, Azure portal, and type in Databricks. There's the Azure Databricks. And what you can do essentially is just sort of create a new workplace, and that's it. Once you've done that, you essentially just launch the workplace. You click, there will be a single sign-on created, and bam, you are in the environment. So the environment looks something like this. So essentially is fairly simple to understand. I won't go into any detail right now, but there are data, compute, and workflows, which essentially for any data engineer is something that is very important. So the data would be, sort of like data repositories. The compute would be everything regarding the computational power, and the workflow essentially is how you wanna sort of connect those tasks together, whether it's a notebook, whether it's a job, stuff like that. So what I'm going to do now is first, I want to show you the compute part. So the compute part is essentially a cluster. And why I'm doing this is just remember when we were discussing, the different type of workers and different type of computations, cluster modes. Again, this is something that is embedded already in Databricks. So just give your cluster a name 1, for instance, and then you have standard, you have single node, and you have high concurrency. So single node would mean that you would have everything on a single node. Standard would be, I have workers, and each worker sort of represents a different machine, and then high concurrency would be a hybrid, essentially capable of doing high concurrency computations and stuff like that. So let's just stick with standard. And every time you do something, there are also different runtimes available for you out of the box. So I'm using LTS, long time support, with Spark 3.2.1 or Scala 2.12. And there are essentially predefined environments available for you. If you're doing anything with machine learning, again, be aware of that. There are also some pre-installed packages for you, whether it's a deep learning, whether it's a shallow learning, any type is already available for you. So I'm just going to stick with a single runtime, and you can see that the number of workers are essentially available right here for me, to see and to understand how much workers do I have, how much jobs essentially will Spark be able to create for me once it sort of start to understand what type of load I want to do. And that's it. Once you're done with that, you can just create a cluster. I don't want to go into advanced options, stuff like that, because it's not part of that. Okay, there is a question. How do we decide which of the two platforms we use for Spark, Azure Databricks, Azure Synapse, and which is less expensive? Okay, good question. So how do you want to decide? Databricks offers essentially the same thing what Synapse Analytics would offer you. Synapse Analytics is, if you want to build up data warehouse, use Synapse. On top of that, once you have the data, you can start grabbing the data out and pushing it into the Databricks. So, I would use Synapse for creating a data warehouse or having all these ETLs, pushing the data somewhere and then sort of, being on top of that. And then you can decide, look, I'm okay, I'll use Azure Synapse to do the analytics, or I can just, plug in the Databricks and start working with Databricks. I hope this answers your question. So, and then there is the data part. So the data part is something that since the question, there is also I need to answer that. So you would have your file system, which is Databricks file system, and you would have database tables. So these database tables need to be created beforehand, whether it's whether the data table resides on a blob store, whether it's on the cluster, on the node, it's up to you. There is essentially this notion that since Databricks is agnostic, it can connect to any data source, and which is true. But then you just have to sort of like represent it right here. So yeah, be aware of that. So this is my file system, and you can see that I've also created a couple of Parquet files here. I have a temp file here. I have org file here. Different, presentation of the data, which can essentially be represented through data tables, making it much easier for you to do the, any type of data analytics or ETL. In terms of the ETL, once you have your cluster running, and let's assume that the cluster is already running, I can create a new notebook. So the notebook would be sort of like a set of instructions. What do you want to do with the data? It can be, ETL driven. So let's say that I will create a notebook that will essentially just grab two landing tables, which are residing in, let's say, in the blob store, and I will push those data from the landing zone to, let's say, any curated zone. I can do that with notebooks. So what would that mean is that I would have to sort of create a connection to Azure Blob Store, have all the instructions, all the need for that, what I want to do with transformation stuff, and then where you want to push it. Of course, whether it's data in CSV and you want to sort of, do any type of transformation and then store it as a Parquet file, notebook would be definitely sort of like a set of instructions. What do you want to do with that, with this particular file or table or folder, up to you. Once you have the notebook created, you can then sort of schedule a job, or you can schedule a workflow, and those can be sort of scheduled in terms of every morning at 3 a.m. fire this notebook, which would sort of grab all the data and from place one and do some transformation and store it at the place two. So this would definitely be a great way to do. So once you create a notebook, you can assign it. You have to assign it to a cluster, and you sort of specify the language. So the language might be Python, Scala, SQL, or R, and you give it a go. You give your notebook a name. What language? It's up to you. In this case, I'm using Python. But the beauty of the Spark, of the Databricks is that every time I'm using a different language, what I can do is just I can just sort of create a let's say like this, and I can start writing a different language. So every time, every cell you sort of create a % and then R or Python or Scala or SQL, and the Databricks will essentially know how to interpret that code, that cell in which language, and it will sort of execute through this language. So I can sort of just create this, and it will understand, okay, this is now R. And you can see that there is also R here. If I would be putting here Python, it essentially switches to Python. And if I execute this, there will be an error because this is not Python. And again, I can sort of create a Scala, and then it's sort of converted to Scala. And again, I would have an error because this is not Scala. and also SQL, it will fail again. This is the beautiful part of the Databricks. Switching this, using these different languages in the same notebook is extremely useful. Okay, now that we've sort of created this segue into the Databricks, first of all, I want to just say I'm using Python. That's it. Every different language that I would need to use, I would need to sort of specify with percentage and then the name of the language. So currently I'm using Python, and if I create Spark and run this, it will give you a context and also the Spark version and the application name. So in this case, it's a Databricks shell, the version of the Spark, the master address of the Spark, and the UI. So the UI will be something that you would be using to understand, how your jobs are created, how, where the data resides, what happens with the server, if there's, any streaming and stuff like that. So every run that I've created with this notebook is essentially written right here. And every time I go on a particular, let's say run, I can click on, and it will be, the Spark will give me this DAC visualization, how the data was essentially understood through a particular section of the code. I can also visualize it through the event timeline, and I can go into a pool. So this would be a Spark pool, any different description, and also going even further through the stages, what has happened with the storage, there are some files there, etc., etc. So again, this is your introduction to understanding what is essentially happening in the background through the single line of code that you essentially introduce to the Spark. So now that we've created a Spark context, we can start using any type of language or any type of task. So in this case, I've just created a simple data frame using PySpark, and it just sort of gives me, okay, this is the presentation of your file. Again, as I said, a couple of modes already now, the transformation and actions. With transformation, nothing is happening until I'm doing something with this particular command. So in this case, even if I say, okay, do something with this particular value, you can see that nothing will essentially be happening until I say, okay, do me a print. A print will essentially be an action that would trigger a Spark job. And this Spark job will be sort of like a written in this UI that we've already seen. So this is the duration of this particular job. We can see that job 100 and 101 are essentially those two jobs that have been triggered through this command. And then if you want to dig in, for troubleshooting, understanding, this is a beautiful way to understand what is going on with the job. Since we've already created the data frame, I can also do the display, which essentially would be an action that would trigger a Spark job. And you can see Spark job 102. And if I go here and sort of refresh this site, I would have 102 displaying the description submitted, all the aggregated data of this particular job. As we've already discussed the Spark architecture, the clusters and UI and virtual machines, again, I want to just sort of give you an illustration about the schema. So the schema would be something extremely important when it comes to the data frames. And first of all, I just want to see what type of data sets do we have. In this case, I'm using, again, file system, and I'm just sort of saying, okay, go to this file system and check if there is any data available. And now what I'm going to do is I will infer the schema, and I'm going to read a Databricks set, which is a diamond CSV file. So again, imagine that you want to sort of get a particular file from your blob store. In this case, it's Databricks dataset. For the sake of simplicity, it could be a location of your blob store where you would be loading a particular dataset. So infer schema is an important part, because if you don't infer the schema, what will happen is not all the data would be, all the columns would be understood correctly. So in this case, as you can see, this is the data set, and there are different data types assigned to, because I said infer schema. If I put the schema, infer schema to false, and I would be running this again, all the data types would essentially be the same, again, the string. So I better put this on back to true so that we have the right data set available. So this is, reading the data from CSV file. Now I can display this data set. Again, I'm using a simple Python script. So display is Python based because I am, the notebook is Python bound, and I'm using the Python. So instead of doing the display in table, I can sort of create also the diagram. So I've basically just repeated this command here, but in this case, what I've done is the notebook itself has this representation of the graphs, and I can do the plot options, click on the plot options, and I can just sort of drag and drop the data, and the data will be sort of beautifully represented in form of a graph. Sort of exploring the data is always something that we need to do. But this transformation is simple. What if we want to do any type of, let's say, inner join in terms of the data? So in this case, what I'm going to do is I will create two data frames, and then one I already have. The other one would be a simple grouping based on the average price, and I will use a simple, again, this is PySpark, join, and then say select me this command, average price and caret. So again, you can see the schema of this data frame. Again, only the schema, because Spark has just sort of created a transformation. There is still no action happening unless I do, a action bound that would sort of create some sort of like a pipeline that the data itself will be created. Again, I can use the explain. Explain will be essentially like a execution plan that will help you sort of understand what's going on in the background. And now that I want to say, give me the count of this data frame 2, again, count means the action. Now that I've sort of created an action, you can see that the Spark has sort of fired this execution plan, and this is something that has been created. Again, I can go and view the job, and now this cyclic graph is much more interesting. But then again, this is bound for understanding, troubleshooting, performance tuning, stuff like that. Since I've already mentioned the performance tuning, caching is, again, something that Spark has been sort of significant about that. So Spark has this ability to sort of store the data into the memory, and you can sort of easily break all this cycle by caching it, which means once you have, I'm just gonna put this on, once you have these graphs, fairly long or complex, you can say, okay, at this point, I want my data to be cached so that I don't go all the way back doing all these transformations, and I can cache my data right here. And every time, the Spark would know, okay, I'm gonna read this cache part and then continue forward on. So this is something that can significantly improve your performance. So the first time you sort of cache the data, you sort of just create you sort of create a cache, and the first time you want to do any type of action, not transformation, but action, it might take a little bit longer. However, every second time, so in this case, I've already had the data cached, but if this would be for the first time, if I would be creating a, let's say, df3, the second time I would fire this action saying, count me the numbers. This would be sort of just flying through the roof. So the first time the count might take much longer, since we are operating with 270,000 rows. And the second time would be just like, split of a second. Okay, so this is how you can sort of cache the data. Again, what we will do now is sort of just explore a little bit more functions with Python and how you want to go about using those. So let's again use this initial reading. In this case, if I want to see what data is already available with Databricks datasets, I can just go down, scroll down, and go to the logs. So the logs are available for you to play around to understand the data right here. So I'm just going to copy paste this and put it in right here. And again, I'm using Python just not to sort of, mismatch with any different language. In this case, I can also use it just like this. It's the same. But for the sake of understanding and for this demo, I've put the Python in front so that you can much easily understand. So in this case, what I'm doing is I'm just creating a Python function that will try to understand this log line and sort of extract a particular data, part of this data from this file. So now that I've created the function, what I want to do is I want to sort of create a structured, like a table from this unstructured data. So in this case, I will create a context. So this is a Spar Context, and I will start sort of preparing these Rdd files that I want to, do all the transformation and then return it into a much better and readable format. So again, now that I've used the count, just to give you an idea, so these raw files are actually context, reading these text files and giving me back how many of those files are here for me to be reading. Again, now that I have the sense of this file right here, I can use this file and use the map function, again, still using Python, and go and start processing, sorry, not processing, but just sort of creating the transformation for a action file. So action would be happening right here. So I can use to data frame, create or replace a view. And what I'm going to do now is I will create a persistent file. And again, this is an action file, an action. And this will sort of create a view that I will be using further down the road. So if we look now, the deck, you can see it's been reading from the text file and converting it and pushing it into this log file. Okay, so since we've used that, now that we can start using any different languages, like in this case, SQL, and I can simply say select from this representation of the data, bam, and it's reading the data. Now that we've persisted the file, now that we've read the files and persisted the data into the data frame, I can sort of use also Scala or R, for reading this data. So in this case, I'm saying %Scala. Now I'm basically starting to write Scala language. And first of all, I will create a context. This context will then give me the sense if I'm interested, for instance, to see the schema. And now I can start again displaying this file, which essentially is just using Scala instead of Python. And again, I'm using Scala here to see the data. Okay, now, as I've already mentioned, data frames and Spark SQL sort of take this advantage, to optimize huge chunks of data when it comes to transformation. And it's much easier, for instance, to write transformations with SQL. So I'll just give you an example. In this case, what happens if I take a date format and I want to cast it as a timestamp? I get the return null. So this means that this operation was not successful. What I need to do essentially is to convert this date format to a Java simple date format, sort of that can handle essentially the time zones. So creating user-defined functions with Spark and Scala is, again, simple. This is Scala. If it would be Spark, PySpark probably would be a little bit simpler, but then, you do it once, and then you have a set of functions in Scala for you to sort of master any type of transformations. And again, this would be sort of like put into the class of functions that you could be reusing multiple times. Now that I've sort of created this, I can start using this function, any given time. But then if you're, sort of like new, you can just, import what has already been done in terms of this Apache Spark SQL function, UDF, and I have, again, this function already available, which I can then use to sort of do the transformation of the date to the UTF file format. So in this case, I can be doing it also in a different manner. If it would be instead of, if this, if you find this user-defined function a little bit harsh, of course, you can sort of be using a simple select statement. So in this case, I need to register the context for this function and then just call it through a SQL context. So I've defined this function through SQL context, and you can see it's right here. It's the same function that I've been using a couple of cells previously. So this one we've created right here. And once I fire this context, I can start using this function in a clean, and creating a clean log file persistent data format. So it's not UTF, but it's in parse datetime timestamp format. Okay, so what happens now? So let's say I've been using Scala to do some data transformation or some SQL to do some data transformation. And as I said a couple of times, yes, those APIs, data frames are interchangeable. But what if I've created this file with Scala and I want to read now this using SQL? Of course, in this case, you can do it, but because I've been running this previously, but normally it would fail. So in this case, what you would need to do is you would need to use this function and simply just say create log file from this data frame. And now this log file would be easily available, accessible to SQL. You can also check this with show tables, and you would see that this clean log file is available through SQL as well. Again, this is fairly easy to read, to manipulate. If you are not really familiar with Scala, no worries. This can also be written in Python. Scala, in sense, would be giving you much better performance in terms of if you would be working with a huge data sets, whereas Python might be a little bit slow. But then again, just keep that in mind. Okay, as I said, schema defined, reading through structured file. This can also be done through Scala. Again, I'm using schema inferred, which we've already seen. And I can also display the data. And now I can say, okay, maybe I'm more fluent in any different language. I can simply call R, import a particular package, and just have my data visualized. Or I can use Scala to do, for instance, any type of data aggregation like joining or any type. In this case, what I'll be doing is I'll be joining the log files with the diamond. So those two, so the diamond dataset and the clean log files, I will try to sort of create a inner join. So if I'll be using inner join, we'll see that the new data would be simply empty because there would be no matches between those two data sets. So those two data sets are completely different. There is no common column. But if I put, instead of inner, I put outer join and then rerun this and then display the data, you would have some data returned to or stored to the new data object. So, and you can see that there is no connection between those two data sets because on the left-hand side, everything is empty. On the right-hand side, you would have data. If you would scroll down, it would eventually be reversed, etc., etc. So now that we have that, I can also sort of store this into a Parquet file. So I can say, write the diamond dataset in Parquet file, and I'll give you a particular path. In this case, it's a Databricks, it's a temp file folder. It can be anything else. It could be anything else. And I'm using the remove function first, just in case I have already stored something. If I would be reading those files directly to Parquet file, I could be, again, using Spark read format Parquet and essentially giving it this file name. And the Spark job has created a Parquet file, which essentially is this diamond. And I can be using, now I can use simply Scala and reading this Parquet data frame. On the other hand, I can also use Scala with SQL. And in this case, I will be creating two semi-large files. And again, all those files are available in Databricks file system and are in CSV format. To have the data persistent, I need to, again, create or replace a temporary view. And if I run this, I would have those two data available. Now I can use SQL, I can use Python, I can use R. And again, show tables, it will give me that those two files have been persisted. Now I can use, whether it's Scala or SQL, doesn't really matter. So essentially, using different languages means that it's super simple. I can also say and do, any transformation in terms of SQL, for instance. If you're more fluent in SQL, all these operations are super easy to interchange. So in this case, what I'm going to do is I will create a new table, and I'll be just taking, a different, not all of the columns, and I will be also doing some transformations along the way. So in this case, I'll be creating the zip code, shortening the zip code, and also doing the right data formats for this particular amount of net total income and stuff like that. So once I've done that, I can simply just run the new file format, and instead of presenting it in this way, I can also say, okay, give me the presentation in, let's say, in map with plot options, and I can simply do just that, simple as that. And I can also create a table using Scala, again, saying, take this table and give me some type of aggregates. Again, this is Scala, SQL, super interchangeable. And now I can read this also through SQL or through Scala. And so the last part would be, again, creating a new clean text through SQL context. So again, I will be creating 1, 2, 3, 4 data sets. So the first one would take everything from this already persisted table through SQL. The second one would sort of create a summary of the zip codes of all the taxes. The third one would sort of create the zip codes and do the count of those zip codes. And the last one would sort of join would create a clean market where it would sort of join all this data together. And again, I can run this. So again, this could be part of your daily operation, part of the notebook. As you can see, also joining, creating with Scala instead of using SQL, or you can use Python, doesn't really matter. It's fairly simple. And all those data sets have been created, having these presentations, or data frames have been created, having this presentation with data types. Now I can essentially see and check what has happened. So in this case, I also see that there are some null values, and I can also remove the null values, saying joined without those that have 0 values. So again, this would be understanding how you would join the different data sets and create new data sets, store them, do the transformation, do the actions, and that's about it. Okay, just to recap, we are running out of time. So Spark is super powerful, general purpose in-memory cluster computational framework. It supports different languages. In this case, Databricks is built on top of the Apache Spark and gives data engineering, all the possibilities to do everything with your data. it's easy to embed in your existing environment, especially Azure. It's, also security is, taken care of. And there are APIs that are super easy to use for any type of operations. And we've seen that, you can do transformation, you can do read, you can do write, using different languages, using different formats. Really depends how, what type of the data sets are you using, which you prefer is fairly simple and easy. Thanks again. Thank you for your time. Wish you a beautiful morning, afternoon, or evening, and feel free to get in contact with me. And if you have any other questions, unmute yourself and we can.
Thank you, Tomaž. Thank you for the wonderful webinar. And friends, there is a feedback link in the chat window, and please give the feedback for the session. So speakers will really value your feedback. So we request you to provide your feedback in the link given in the chat window. You can use the questions using Q&A panel. So while you pick up your questions, so I request Tomaž to talk a few words about his pre-con that he is going to do in the September this year.
Thank you.
Tomaž, if you can speak a few words about what you're going to cover in the 8-hour training that you're doing in September.
Thank you. Yeah. So as we've seen today, I've rushed through the through this 60-minute session. But what we'll be doing in the seminar is we'll sort of take it fairly easy and dive into what Spark is, how to set up a Spark, and we'll dive into different languages, get data from different sources, do something with the data, whether it's just reading the data, doing transformation the data, whether it's a blob storage, whether it's something else, and then essentially putting the data into the blob store, and then creating tables, reading the tables, all using SQL, PySpark, Python, and Scala. And we'll be diving also into different functions for Scala. So you will definitely get to understand Scala, get to understand Python and Spark. And at the end, we will also, have sort of like play around with also other APIs, not only data engineering tasks, but also sometimes data engineers need to understand the data. And so we'll also look into some those statistical functions and stuff like that you will find useful. At the end of this pre-con, you will be able to use Spark as a standalone environment, whether it's you've sort of set it up in the cloud, or whether you're using a Synapse, and you will be able to sort of create any type of transformation for your data in the cloud, in the Synapse, in the HD inside, in any different platform that essentially you will be using. So it will sort of boost your knowledge, how to work with the data, how to do the transformation, how to do the ETL, how to do the architectural part, essentially getting closer to understanding what Spark is.
Yeah, so it's a great coverage, friends. So what you have seen today is just a sample. So Tomaž is going to cover a lot more than what you have seen today. So here is the discount code for all of you friends. 60 Steal It will give you 60% off on the training class. And there is one question, Tomaž, in the Q&A panel. Elaborate on action versus transformation in Spark.
Sorry, can you repeat the question?
Elaborate on action versus transformation in Spark.
Okay. So the transformation is something that Spark sort of prepares before doing. And you could have many different transformations prepared, but essentially nothing will happen. So try to imagine a couple of Rdd files that are having different aggregations, whether it's wide, whether it's narrow, and you sort of create a transformation, without essentially giving it an action. Without giving it an action, there will be no Rdd files in the background created. Once you've sort of created a action, there will be a new Rdd file in the background created. Again, Rdd in terms of low Spark level, because you would be using, of course, the structured API to essentially read those new Rdd files created. So the difference is transformation is sort of just preparing what you will do with the data, versus action is something that is sort of essentially creating a new aggregation of this particular transformation. I hope I understand it. I hope I explain it clearer
So
now.
there is another question from Sri.
Okay.
Where can we get the best and easy to understand documentation for learning about the architecture of Spark?
So the best is to go on a Apache Spark website. There is essentially the best, yes. The native explanation of what Spark is. I find since the authors of Spark and Databricks are, it's the same group of people. There might also be a great explanation of Spark in any Databricks book. So, but essentially, go to Apache Spark, and there are documentations available which will definitely have a good introduction explanation of those topics. Thank you. If there are no further questions.
With this, we are done today. There are no more questions, Tomaž. I request all the attendees to please give the feedback using the link available in the chat window. And an important note is that pre-con price is going to increase from August 1st onwards. So if you wish to book a pre-con today, next few days are the good days for you. So this is the lowest price that you will ever get. So please go ahead and book. So with this, friends, we are done for today. Thank you, everyone. Thank you for attending. And especially thanks, Tomaž, for taking out time from your busy schedule to deliver a webinar for Data Platform Geeks audience. Thank you very much.
Thank you. Thanks for having me. And thanks, everyone, for attending today's session. Cheers.